Hello, ladies and gentlemen. I hope I'm going live about now, back-to-back stream days. So I'm very happy to be able to do that. Had a long day at work, came home, freshened up a little bit, and then thought, you know what? I missed out on the RTX 1590 coverage because my stream very rudely crashed that day, and I just don't leave half-finished streams online. And so the RTX 5080 reviews are out today, and I thought, well, why don't we take a look at them? I think that they're very much actually painting a narrative that is probably worse for the RTX 50 series than the 5090. At least the 5090 across the board had like the excuse of being the absolute flagship, the most expensive thing. But the RTX 5080 being the same price as the RTX 4080 Super, I don't even count the regular RTX 4080 that started at $1,200. I think that product never sold that much. There's a reason why they launched a 4080 Super that was both a bit better and noticeably cheaper, which they really didn't do for any other cards across the lineup. So, and considering that all of it is still way more expensive than like the $700 RTX 3080, which yes, had like limited amount of memory with 10 gigabytes, but now the 5080 for its price has a similarly limited, ridiculous amount of memory. So yeah, this is why I thought it would be good to cover that. We've already covered some of the bad Nvidia news yesterday. In fact, a lot of the reviews that are coming out for the 5080 apparently had time to integrate some DeepSeek jokes about like Nvidia stock, which was up 8% yesterday after dropping 16% the day before that. But now today they're down again around 5%. So yeah, it's been a roller coaster for Nvidia, especially for investors. Today we are definitely not covering this side of Nvidia. We're not investor talk guys here. But we will cover their latest consumer product, the RTX 5080. Beyond that, we'll have a quick look at the first reviews, or to be more precise, the first battery test we're getting for the Galaxy S25 Ultra. You see, the stuff is not entirely new. It's like 3 days old. I hope that by this point, I would have some stuff to cover from the sources that I like. The Tech Chap, GSM Arena, Tech Droider does very good battery life tests. But alas, we still don't have it. I think it's good to look at the little bit of data that we have right now, get a little bit of a prediction going, and then over the course of the week, I'm not sure if I'll be able to stream tomorrow. I'll definitely not be able to stream on Friday, most likely, but I'll let you know. So this is why we are covering this stuff, basically getting ourselves ready for even more data, more detailed stuff. Don't worry, we will not have rants today, similar to yesterday's rant about Samsung's Project Muhan. So this is going to be, while yes, we are covering a more negative piece of tech news, like the pretty lackluster 4080 Ti reviews, 5080 reviews, which is so disappointing. It might as well have been like a 4080 Ti Super. And to be honest, that uplift should have been given to the 4080 Super 2, it being only like 3-4% over the regular 4080 was already not that great, but at least it got a price decrease. So I am rambling a little bit. That's about it for the intro for today. Small shout out for you guys to do the YouTube jazz, as we call it around here. Subscribe to the channel, like the video, share it out with anybody who you think might enjoy it, and comment. You see, I love interacting with a lively live chat. Obviously, I know my timing varies, so it's hard for you to really predict whenever I'm going to stream. So hit the notification bell to actually know when I'm going live next. Hello to Riveting Tail Chap in the comments saying, leaving that like and comment for the algorithm. Thank you so much. You're doing the Lord's work, brother. And without further ado, let's get started with the RTX 5080 reviews. Man, I'm sure I'm the first guy to be making that joke.
Here it is. NVIDIA's
As always,
new...
let me know if the audio and video quality is working all right for you. You guys know how paranoid I can be about that, whether I'm too loud or they are too loud. I cannot test each and every single video, especially if I react to some stuff more spontaneously. From everything that I've seen, I should be fine with a LTT video. Obviously, for way better coverage than LTT on hardware, go to Hardware Unboxed, go to Gamers Nexus. But we are reacting to LTT because these are more mass-friendly reviews. They do a bit more explaining, which I think might be necessary, primarily because I have an Apple-focused audience. So some of the terms being used and some of the discussions here might be a little bit newer to you. I do try to follow PC hardware as much as I can, though I cannot find the time for that as much as I used to. However, because I did get to cover at least halfway through the 5090 reviews, I do have a little bit of a leg up maybe on you. So if you need help with anything, hopefully I can answer some questions, explain some stuff to you. We can have some nice discussions. So join me. Let's get started.
RTX 5080. Compared to its predecessor, the 4080 Super, it is around 15% faster.
That's actually one of the higher findings. A lot of them are now more around the 10 to 12% range, which, while you might think, oh, 15% is not that much more than 10 or 12%, but consider from 10 to 15%, that's a 33% uplift, right? Not overall, but just that difference in the difference. So whatever games you test, at what settings you test them, at what resolution you test them, and potentially if you're testing them, though by now basically everyone has moved on to the 9800X 3D, but let's say you test maybe with like the 9700X or the 7800X 3D still, right? You might be hitting bottlenecks, especially at resolutions below 4K, maybe already even at 1440p rather than just at 1080p, which was more the case with like the 40 series. So yeah, there will be differences from review to review. That doesn't mean that one review is lying. Usually there is some bias in the sense that maybe some people really are like, oh, I'm never gonna test ray traced games because like, oh, that just benefits Nvidia. But fact is, like, look at Indiana Jones. That's hard. I believe Indiana Jones includes hardware RT. But then Alan Wake 2, the monkey game, the Chinese monkey game, what was it called? Black Myth Wukong. Like, there is so many games that have either ray tracing built in, at least on a software level, or they offer like extreme ray tracing presets like RT Overdrive and Cyberpunk. So it's really gonna hard to escape RT, especially if you like AAA single player games, beautiful games, high production games, story-driven games, expensive games. So I myself actually would really focus on RT, and in fact, RT is kind of the thing that I do believe for now really differentiates the peak capabilities of PC versus consoles. My God, why is my stream acting up again? 1.1% frame loss. Why is it always happening around 7-8 p.m.? Jesus Christ. Seems to be getting a little bit better. Let me guys know if my stream is unstable. Otherwise, I'll just declare that RTX coverage is like cursed or whatever. But yeah, you're just seeing my home screen right now because OBS doesn't show up in the preview. But like, I have no idea why I just lost 377 frames. Just lost another 20. Jesus Christ. I'll probably have to tune to some presets in OBS, or I'll have to rely on like maybe 5G for streaming. I have no idea what is happening with my home internet in the last 2 weeks. It's really getting unforgivable because I'm relying on this shit for my hobby here. Otherwise, I'll just complain. So let's see. For now, it seems somewhat stabilized. Let me continue.
in games that use its new features. It's faster in AI, as long as you don't need more than 16 gigs
Mr.
of RAM.
George Best joining the chat. Oh, hello there, Mark. Is that a joke from the room of like, oh, hi, Mark. Good to see you. Been having issues commenting on the Mac, so here I am on my phone. Was looking at S25 reviews, and so some losing their camera rings like they're glued. Yeah, I've seen that. I'm not sure if it's a meme, but from what I understand, there weren't like a hard connected already on the previous Galaxy Z Fold and Flip phones. So I don't think why they would be very different. Yeah, if anything, I just think that the entire concept of those extra rings, for one, is very last minute, not necessarily for the S25 series, but just as like a design element. It was never part of what they're doing. Plus, I just think it's a bad design. I think it looks bad. I think it makes it look unnecessarily thick. I don't think it contributes anything to durability. So yeah, as always, like just in recent years, it's so bad because Samsung still builds great screens, right? Great memory, good storage. Their modems are, their processors are, but at least they don't insist on using them, right? That's an admirable thing. I think if you know that your own hardware cannot compete, I think it's a sign of strength to say, oh, this year we're actually going to use the Snapdragon chips across the board. But like, I feel like their camera stuff, all that back design, where some stuff gets curvier, some stuff gets harder edges, it just feels, and then the cameras, for one, I always actually admired, but for the last couple of years, I've admired that Samsung kept like the camera arrangement from the Note series, right? I was like, oh, you're not changing it around just for the sakes of changing it around. But the problem with then is now Samsung just added those extra rings, did it in the cheapest way, and then everything around that is just like randomly changing still. It's like, oh, the device was rounded off, very recognizable as a Note or an S Ultra device. Nah, it's gonna look like an iPhone 12 now. Doesn't even copy like the slightly soft edges of the iPhone 15 and 16. Like, oh, we had like actually like 90 degrees corners, so like the especially with the S Pen, right, we just optimized for the maximum usable space. It looked different than the iPhone. You know what, we're just gonna round it off the same way the iPhone does, right? I just feel like there's so much randomness that I don't appreciate when people complain about like the stovetop camera design on the back of iPhones, right? That triangle. I'm like, yeah, obviously Apple should change it if like at some point the cameras become so large that it's better to align them vertically or horizontally, right? Whatever floats Apple's boat. But why should they change it randomly? If the motherboard is designed around supporting this design, if the other components like the battery, the speakers, the antennas are built that way, like why should they randomly reposition them around in like a circle exactly in the middle? I'm not saying that the circle exactly in the center is bad. In fact, it can be quite good, but that would require a lot of internal redesigns, and we don't even know if the end product would be better. So I like designs, I like redesigns, but I don't like redesigns for the sake of redesign. To be honest, Samsung has this design locked in with their S24 series. Why on earth would they add the ring? No idea. And make it look like iPhones? Well, they make it look like iPhones to make it look like iPhones. In certain regions like China, that's partially all that matters. Maybe not necessarily hardware-wise, but there's a reason, and we covered that yesterday, like why ColorOS 15 is basically a blatant iOS copy, right? You don't just fall down and accidentally land on your Android skin looking the exact same way as iOS. You do that very deliberately. Also, waiting for Intel to release a high-end GPU, like imagine B690. Unfortunately, I don't think that's going to happen. The utilization of like the B580 and stuff like that is pretty low in comparison to their die size. Like they do have die sizes more comparable to like the 5070 Ti and something like that. But then they perform more like a 5060 or 5060 Ti. So whatever Intel is currently doing, it seems to be doing quite well for ray tracing, for AI stuff, right? All that stuff that might matter to like Disney running a server for their big movies, or for AI inferencing and training and shit like that. Granted, nobody's buying Intel for any of that either right now, but at least Intel can hope. But when it comes to just traditional rasterization, the GPU dies are positively huge. Like they're 5 nanometer GPUs. So even if you consider that 4 nanometer is a tiny bit more dense, right? The fact that they literally utilize their die space 20, 25, 30% less efficiently than like an RTX 40 series card, there is some disaster looming for Intel unless they really turn it around. Like, and don't forget, a B690 would not benefit you the same way that like a $220 B580 does. The B580 is so irrelevant in the grand scheme of things because it's cheapish, right? It's not as expensive to produce, but they also know that it's not going to be bought by enthusiasts, so they might as well sell it at cost or even at a loss just to potentially gain any market share, right? With a B690, believe me, that will not be the case. And at that point, once they want to charge you extra, like to make a profit, if they still have that like that die space utilization issue, then they might end up with a product that is as good of a value as an RTX card, and those RTX cards have a 50 to 60 to 70% profit margin, depending on which card class of card we're talking about. So while I do understand and I do appreciate more competition in the market space in general, for now there are reasons why Nvidia wins. Like AMD hopefully will catch up a little bit with ray tracing with the 90 series. AMD will still not catch up with AI, even if FSR4 is much better than FSR3. It will most likely not match the capabilities of the transformer model of DLSS4. And Intel, while they might technically have similar capabilities for AI and ray tracing, at least relative to raster, while their raster is terrible, and they don't have the long-term developer support of either AMD and Nvidia. So it's really hard. I'm not seeing that like 80% market share of Nvidia in the GPU space dwindling down anytime soon. If anything, I just see people, like more people potentially saying, you know what? Especially once like the PS6 comes out or even the Nintendo Switch 2, they'll be like, you know what? Maybe I'm good with like a decent laptop, or hell, maybe I'm getting a Mac, right? Because I've heard the user experience of Apple Silicon is so good, and I can game on my console, or maybe I'll build myself a dedicated PC, but I'm just not going to go as crazy, right? I'm just going to focus on gaming, not going to have all the other crazy stuff. So yeah, it's hard to predict right now. So I think we could actually see like the PC GPU market shrink, which Nvidia doesn't care about because they sell their GPUs to like the server stuff. Let's continue though.
Your model. It's more efficient, even though it draws more power overall.
Yeah, I mean, it's like 5% more efficient.
And it's got a great cooler design, as long as you don't mind heating up your CPU.
Yeah, that's unfortunate, but at least the lower power consumption of a 5080 versus a 5090 will result in you heating up your CPU less.
And that's it. That's the most positive spin we can put on this thing.
Yeah.
Why the do we need all of these caveats when we say the new one is better than the old one? I mean,
Yeah, like I guess if you the problem is when we are talking about stuff like new media encoders here, right? Like there is realistically no way, shape, or form in which the new media encoders are good enough to justify you still getting a 16 gigabyte card, right? If you actually plan on utilizing the AV1 codec and you want something that is truly super duper efficient and powerful, whatever, right? You would probably want something more like a 5080 Ti, right? Like a 24 gigabyte card. So it's actually a little bit future proof. Or then you overspent and get a 5090, which is overkill for all of those things. But like, like if you really just want a good card for encoding videos, some video editing, at that point, get yourself a 4080 that is way cheaper now than a 5080. Or get yourself an AMD card, which granted are not the best at encoding, or even better, just get yourself a Mac for that specific video editing task. And you'll be better off. And that is the problem. Like there is so little value to be gained. Like the efficiency benefits are minimal. The AI benefits are kind of there, but again, they are very much constrained by that 16 gigabyte limit. That raster improvement is okay, but then the ray tracing improvement is actually kind of bad because it's absolutely in lockstep with the improvement for rasterization. But it doesn't have, for one, extra memory so that it actually can fit potentially a large 4K without upscaling like RT workload. But also just the usually we just got used to like Nvidia crazily improving ray tracing after the 20 series, right? Every generation improved ray tracing more than it improved raster, and the fact that it's not happening now and it's happening on a VRAM limited card, it's just embarrassing. I'm so glad I'm blessed with the fact that my favorite games are ones from 2 decades ago and run perfectly fine on the Mac using VMware. Yeah, I get. Yeah, well, that's true, right? I mean, I believe the latest version of Parallels supports like DX12, and you definitely can run stuff through like the translation layers and things like that. But yeah, if you are running like way older even than DX9 games, right? Then at that point you can emulate pretty much anything, right? Yeah, absolutely. I mean, technically for that you wouldn't even need like VMware, right? You could even run like a if you literally mean like 20 years old, you could run like a Windows XP emulator and it probably would have like incredible performance.
isn't the point of the new one to be clearly and substantially better?
Well, it is better. In cranked out Cyberpunk at 4K, it not only beats the 4080 Super.
Yeah, this is the problem, right? So here we see the benefits of the improvement in memory bandwidth by using GDDR7 rather than 6X. But that's one scenario, and it's not like it's a good uplift. If everything was like that, it wouldn't be bad. But you can see that you probably wouldn't be running it even at 2160p. You would probably run it at like 1440p internally. Maybe you would make it to 4K with like a DLSS quality mode, and at that point your frame rate would then actually be like 60 fps. I mean, like also for the 1% lows. And now your bandwidth advantage actually matters less because you're running internally at a low resolution. So now percentage wise that gap will shrink again. Yeah, and yeah, it's really disappointing shit show. It's a very unbalanced card. Mr. George Bass, may I ask, Mark, what are your favorite games? Personally, I play RTS games like Red Alert and Generals. My favorite games are almost universally Look, I like me some of the Nintendo classics across like the Pokemon series. That's like childhood memories. That's not really on like a connoisseur level of like, oh, these games are amazing, right? But like Pokemon Emerald, Pokemon Platinum, I could play all day. Um, um, but for me personally, the games that resonate the most with me are God of War. Like God of War 2018 and Ragnarok are probably like, I count them almost as one game because they're so good and so connected, and it feels like they two doesn't lose a step versus one. Um, I love The Last of Us. I love The Last of Us 1. It's probably my favorite game ever. The Last of Us Part 2 has amazing gameplay and the story I really liked playing through once, and a phenomenal no return mode that I put 100 hours in on my PS5, but I'm probably not going to replay the story. I love Ghost of Tsushima, and yes, I'm listing a lot of PlayStation exclusives right now, but that's because I love story-driven games. I love games that have a beautiful atmosphere. I love games that challenge technologically, like the system they are running on. So it's also exciting for me to analyze it, like the frame rate, the resolution, the use of newer rendering technologies, right? So that's my cup of tea. I know, like, it's not the typical PC answer, PC MR answer here, but yeah, those are the games I like.
But it even gives the 4090 a run for its money. But it's such a mixed bag that in other situations, it barely outcompetes the 79.
Yeah, and this is at 4K. So here with Ultra High Preset Plus, now granted this is without ray tracing, but we still clearly have not hit any bandwidth limitations, right? And it does barely outperform the 7900 XTX. It probably would do a lot better in comparison if we're talking RT on. But even then, like, there will be scenarios soon, especially if you want 4K native, which you probably don't need thanks to DLSS 4. But like the 24 gigabytes RAM buffer on the 7900 XTX, that's just a different class of potential here.
900 XTX, the flagship GPU that made AMD think, you know, maybe we just shouldn't do flagships anymore.
Yeah.
Hey.
I mean, the issue is the 9070 XT will roughly match the 7900 XTX, probably fall in somewhere between the 7900 XT and XTX, and will be more efficient and will have better rasterization. But then again, if you were somebody who looked at, for example, at buying like the 7900 XT rather than the XTX, and that card had 20 gigs of RAM, often was available for around $750. And now, even if the 9070 XT is $650 or something like that, now it's a 16 gigabyte card. Now, again, you're buying something that roughly matches the RAM capabilities of the current gen consoles, just around the corner when PC is really stepping up its game. Like games like Indiana Jones, games like the newest Doom, if you are actually enable the highest settings there and high quality textures, the highest quality ray tracing, not only will you potentially hit performance problems, but especially at higher resolutions, you will hit memory issues, which if you're somebody like me and perfectly fine playing, let's say, between 60 and 90 FPS, right? Let's say 90 FPS is the average, 60 FPS is like your 1% lows. That's, to me, that's an almost perfect gaming experience. Yes, between 90 and 120 would be even better, but I wouldn't give up too much visual clarity for that. So if, let's say, you could that simply from a computational perspective of your card, now how shitty does it feel if suddenly you cannot do that simply because of your VRAM? That's just crazy shit. And Apple has been criticized for like 8 gigabytes of RAM on like the M1 up to the M3 Max, right? And the M4 iPad Pro. But like consider that the M4 Mac Mini has 16 gigs of RAM, in a $600 product. And yes, that RAM, even if let's say 4 gigabytes are always captured by the operating system, right? That leads you 12 gigabytes left for everything else. At $1,400, you get a 24 gigabyte system that actually has decent performance across both CPU and GPU. And yes, while it won't game like a 4080, like a 5080, at least it offers you a world of other opportunities. Man, I am having so many frame drops this stream, but you know what? I'm not gonna close it. Just let me know if it ever becomes unwatchable, right? At least let me know that.
Glass half full, at least they didn't raise the price, and we did find some situations where the 5080 offers a pretty compelling use case. And if you don't mind the weirdness of generated frames, maybe Nvidia's onto something with the neural.
No, the problem is none of this is actually real right now, right? Like there's no neural rendering right now on any game, like not even as a tech demo in that regard. Well, as a tech demo if you consider like the video, but also, by the way, like this idea that like what do you mean standard material single layer? Like, do you really think that that's how games look? Maybe like a cheaply optimized game or whatever, but I've seen plenty of games with good textures. So newer materials basically mean that previously you could use the AI accelerators, of course, for AI stuff, right? So if they generated you actually more pixels, they did it because your raster shaders generated pixels as a baseline, right? So whether it's frame generation or just upscaling or super sampling or stuff like that, right? That's what the AI did. In theory, now with neural rendering on the 50 series cards, the AI is so tightly integrated into everything else that in theory, it could actually render stuff for you. Now, it suffers from the fact that the AI accelerators are not FP32, so, well, they can be, but that's very low performance levels. Usually you run them at like FP16 or more likely integer 8, or what NVIDIA is pushing right now, integer 4. And that's a low level of precision. So doing that for graphical rendering really can fuck you up. So there is a reason why NVIDIA showed you off stuff like neural materials or neural face rendering, but no game to actually support it. Mr. George Best, I do not know why NVIDIA is gatekeeping their RAM to the more expensive GPUs. Well, that's so people buy their more expensive GPUs. It's primarily because the people who actually utilize that GPU in a serious way, so pros and right now AI guys, they are the people willing to pay double, triple, quadruple the amount for the card. So to them, an RTX 5090 with 32 gigs of RAM is actually a really good deal. And they would probably pay $6,000 for an RTX 5090 minus, as long as it has 64 gigs of RAM, because their RAM, to them, RAM at that point is more important than even the raw performance level, because to them, RAM is raw performance. I know they want to sell more of the high end, but like, why compromise the middle? Yeah, I guess like something like the 5070 Ti, right, where it's like 16 gigabytes, but for $800 or $750, that's the problem at that price point is then it's not a bad amount of memory, but now you're really cutting off performance from the already underwhelming 5080. If the 5080 was $800, I honestly think it would be pretty good. It wouldn't be as efficient as I would like it to be. I don't think it would push any technical boundaries, but I don't think it would be bad or insulting to the audience. But then when we get to like the 4070, right, a $550 card with 12 gigabytes of GDDR7 memory, right, which DDR7 is more expensive than 6 or 6X, at that point, really? You couldn't make it like just the 4070 Ti, but with GDDR6 memory, right, to make it a little cheaper. Or hell, if you're using GDDR7 memory on a 192-bit bus, you know what you could do? The thing that Apple did for the M3 Pro MacBook Pro. Give it 18 gigabytes of memory, right? Because GDDR7 supports 50% more dense RAM modules. What you could do, right, you could use, instead of 2 gigabyte modules, 6 of them, you could use 3 gigabyte modules. Now you would end up with an 18 gigabyte card, bump up the price from 550 to 600 bucks, and you would have actually a decent product that could be pretty good at video rendering for a low price, because it would still have all the encoders and decoders. It would be a great card for like small form factor PCs. But yeah, that probably makes too much sense.
Rendering stuff.
We're going to tell you more about it after I nearly render, a better way to sell your used hardware.
Is it available?
Yeah.
Is it available?
Yeah. Again?
Is it available? Just let our sponsor Jawa buy your old GPUs. No need for more stupid questions.
Yeah. So are you interested?
No.
Before we explore the wildlands of AI-assisted rendering, let's get our bearings with some good old-fashioned 1440p results. All raster, no DLSS.
So you can, this is, by the way, these results will have CPU limitations, especially at 1440p. You sometimes might not see it exactly, but these large cards, relatively, especially the 5090, but like a 70, and this is why I hate that LTT really wants to automate all their review stuff. It leads them repeatedly to use outdated tech. So this is why I actually wanted to react to this review, because the reason why I recommend Hardware Unboxed or Gamers Nexus really does not have something to do with like a big dislike of LTT. I'm not the biggest fan, but overall I'm fine with at least their PC coverage. But sincerely, guys, we are now like so many months into the AMD 9000 series CPUs. Why are they still using a 7800X 3D? At least the memory they're using at 6,000 megatransfers is fine, but they could be using a 9000 and 9800X 3D, maybe with like 6,400 megatransfers per second. Yeah, so this is something I really don't get. It just feels lazy to me. It just feels like they really want to maintain their automated test bench and changing out hardware there, even if technically, obviously, the 9800X 3D could sit in the same socket as the 7800X 3D. To them, that's just not worth it.
Upscaling or ray tracing. In Cyberpunk, the 5080 makes a great first
Angelica, welcome to the chat. Yeah, I'm also glad that I found some time today.
with a 20% lead over the 4080 Super.
Yes, you can see, by the way, here, these are scenarios, obviously, where you're not CPU limited, because otherwise the 1490 and the 5090 would not be delivering superior results. But then again, sometimes NVIDIA cards and sometimes NVIDIA or AMD cards will actually react differently to the CPU they're paired with, right? So the overhead might be a little different. So just use the latest CPUs, just use the fastest CPU. Please don't hold back, because you need to automate everything. Also, testing Alan Wake with RT off. Also, FSR native resolution, I think I already commented on that in the 5090 video that obviously does not exist anymore. It probably just is their form of anti-aliasing, but yeah, obviously it's not ideal what we're seeing here.
Then in Alan Wake, the 5080 brings a decent generational uplift that brings 1% low FPS into the triple digits. But also it only barely outpaces the 7900 XTX here. In F124, things look even less exciting.
And also, like, the game selection of, like, if you have a small amount of games, you really need to be careful in what you test. And I feel like these games were chosen specifically for, like, them being easy to automate. Like, racing games are notoriously easy to control in that regard. So I'm just, like, I really wanted to react to this because when I was reacting to the 5090 review by LTT, I really saw these flaws, and I was like, guys, please go to Hardware Unbox, go to Gamers Nexus. Now, we don't need to do that right now because obviously you can take my word. If you go there, you will see similar differences, maybe 10% uplifts rather than 15 here. But yeah, there are just issues here with the testing that I don't like.
The 5080 failing to overtake AMD's now 2-year-old flagship, and only offering a measly 7-ish% uplift over the 4080 Super. Does it get any better? No.
No.
No again, and triple no.
Yeah, so also a shout out to the Sony games, yeah, right, like the Returnal, The Last of Us Part 1. The Last of Us Part 2 is coming out soon on PC, but it's pretty much running the same engine as Last of Us Part 1 Remake, so shouldn't push PC hardware that much more. I would argue Spider-Man 2 is more interesting. Will be interesting to see how much it pushes stuff like RT Shadows versus Spider-Man Remastered, because unfortunately, that feature does not exist on the console, but this feature, therefore, is also not as well fleshed out. Like the RT Shadows in Spider-Man Remastered on PC, for example, are a lot more prone to artifacts than the regular shadows that you just see. Well, you can also enable them on PC, but just the ones that came from console originally.
Why does the last-gen 4070 Ti Super make everything else here look like an overpriced joke?
Well, that's because it's also an overpriced joke. And looking slightly better makes everything else look like an overpriced joke. That's how it works.
At least Black Myth Wukong provides a reason for the 5080 to exist, but overall, I'm just kind of getting sad reading you all these charts, and you can expect a roughly 10% uplift over the 4080 Super and just 7% over the 7900 XTX. If you're curious about the 4080 non-Super, there's a reason we called it the 4080 cheaper. It performs basically identically, and you can't buy it anymore, so we opted to use our limited graph space for older cards that might actually be worth it.
That's correct.
All right.
I
well,
don't
maybe
have
the story
a problem
changes
with
at
that.
4K. Ooh. Yeah, okay. So it's a bit...
Well, yeah, the issue is now we benefit like from higher bandwidth overall, but actually once you enable RT in certain of these games, now you will hit potential like 13, 14, 15 gigabytes of memory usage. And while there are very few titles that break 16 gigabytes even at 4K, and you probably wouldn't want to play at 5K here, but let's say you're running 4K at that point with RT on, and those RT effects get much more demanding over time. And let's say you want to maybe run at the highest possible quality at 4K, which would be 4K with DLAA, right? Now you're utilizing even more bandwidth and RAM from your card, and now you're having issues potentially with 16 gigabytes, especially by the time like a PS6 rolls around.
A bit happier, but this feels a little bit like going from Bridge to Terabithia to Dead Poet Society. On average, the 5080 takes a commanding 18% lead over its predecessor, which is good, but that parade gets somewhat rained on by its mere 10% lead over the 7900 XTX.
Now, the 7900 XTX does have downsides too. I don't want to say like RAM is absolutely everything, but like it does have worse media encoders, right? It is less efficient. But if you are okay with buying a 16 gigabyte card, then you would be stupid, in my opinion, to either not spend much less money on a 4080 Super, right, which will not age worse than the 5080, or instead, much more smartly, you wait for an RX 9070 XT, not necessarily even to buy it, but at least to wait for it to bring down the pricing of the 5080 or 4080. So, or you save a ton more money and you buy like a 7800 XT. Right, like the $500 card with the same amount of memory as this $1,000 card. And I don't want to focus too much on memory. I think if this card was 20 gigabytes, honestly, it would be perfect. But yeah, that's not what NVIDIA chose to do.
Are a couple of standouts that merit specific mention here. Black Myth Wukong has the 5080 taking a price.
Or, I mean, it is GDDR7, right? Do what I recommended for the 5070. Use higher density memory modules and give it 24 gigabytes rather than 16. And you know why I know that's possible? Because that's what they will be doing for the RTX 5090 mobile. And the RTX 5090 mobile uses the die of the RTX 5080 desktop.
Appropriate lead over the 7900X.
Yeah, I'll argue the 7900 XTX is $850 for real, while the $999 MSRP here is for the Founders Edition. I have not seen AIB models for the 5080 anywhere below $1,200. Realistically, this thing is like 40% more expensive than the 7900 XTX.
With a worthwhile uplift over the 4080 Super, and that's also true in Cyberpunk, where, again, the 5080 nearly catches the 4090, losing only in the less important average FPS. But that one result there, it's less of a trend and more of just an outlier. In other titles, it seems like the 5080 is content to just be its disappointing self. Better, but not better enough. Of course, Nvidia doesn't think that traditional raster rendering is the way forward. No. Their way forward is with the AI GPU hardware that made them the most valuable company in the world, and any conflicting data would almost certainly mean a cratering stock price. So, with the AI
so that was funny because obviously we did cover briefly like the DeepSeek situation and the Nvidia stock price drop yesterday. Yeah, we covered it yesterday. It happened the day before. Yesterday it was on the rise. Now today it's already dropping again because they found out that the actual inferencing, like the server live compute for the DeepSeek AI, the R1 model, is actually happening on Huawei like self-made Chinese GPUs rather than NVIDIA hardware. NVIDIA hardware is used for training the data, not for actually computing it live, which probably also explains why they were able to claim so many fewer models, because if they used a lot of the high baseline of open source AI LLMs, and then they maybe stole a little bit of magic from OpenAI, right? So they probably were able to get away with training very little data on whatever NVIDIA hardware they had, and they just never thought of building a huge infrastructure of NVIDIA cards because they were like, oh, we have those Huawei cards for the actual inferencing. So that's actually pretty interesting, and I'll be interested to see how efficient those cards are, right? Because obviously it's one thing to be able to compute, but if they're based on like a more of a 7-nanometer equivalent, that can be bad, especially if also the architecture is simply inferior. So yeah, it's going to be interesting how it all plays out. We have already seen that like Microsoft and Google and Amazon all want to build their own hardware, right? They're fine with training on NVIDIA hardware, but the actual inferencing, they would love to run on their own hardware to make it a lot cheaper, to guarantee supply, because NVIDIA supply is really hit and miss, unfortunately. So yeah, it's going to be interesting if DeepSeek actually pushes more of Western companies into relying less on NVIDIA, not maybe so much for training, but at least for like the actual like live compute when a person makes a query to like your chatbot. Steve, oh, I believe I forgot the shout out to the MarkTech Pro Max YouTube channel members. Shout out to Steve, Angelica, and Max Maximus. Steve joining chat saying hi, listening in the gym. Fully understand you, bro. Gym is very, very important. I have not been able to go to the gym this week yet too much. So I'll try to remedy it as soon as possible. So good luck to you.
boom in mind, NVIDIA focused most of their architectural upgrades on that.
If you want to learn more about the architectural and technology upgrades, we highly recommend you check out our 5090 review, where we spend a bit more time explaining what everything means. What really matters for gamers is how this card differs from the 4080 and 4080 Super. It's not much. We're still on TSMC's 4N process node, but at the same MSRP. We get 4 more streaming multiprocessors in the 4080 Super, along with a clock speed bump and a memory swap from 16GB of GDR6X to 16GB of GDR7. That all explains why raw gaming performance isn't improved much. The bigger improvements come in the form of next generation Nvidia ray tracing, RT cores, and AI accelerating tensor cores. The tensor cores also now have hardware support for FP4 calculations for improved performance and memory usage with lightweight AI models, and are more tightly integrated with CUDA cores to make way for the sci-fi sounding neural rendering. For hypothetical future gamers, these neural rendering techniques actually sound really cool, and they might turn out great, but gamers shouldn't feel pressure to upgrade until a must-play title that uses them hits the Steam store. Instead, feel pressured to buy our Precision Multi-Bit Screwdriver bundle from lttstore.com. Anywho, those working with high-end video might upgrade for the new Media Engine on the 5000 series.
I mean, that's a CPU comparison, also, which is completely worthless. Yeah, but the 50 series does supposedly have better encoders than the 40 series, so that's at least something, right?
That provide support for 422 chroma subsampling. In a nutshell, this means much higher quality hardware accelerated video encoding, which will be a boon for professionals and anyone who likes streaming their games to a handheld or lightweight decoding box. We're also stoked about DisplayPort 2.1 UHBR20. The 5080 can drive 4K 240Hz with no display stream compression, and even go higher with DSC, which doesn't impact image quality as far as our eyes can perceive. That means no compromises between image quality and latency and responsiveness.
Let's move on to ray tracing, where, yeah, Nvidia is really just competing against themselves here. But as more big titles list ray tracing as a minimum requirement, it's becoming something that just can't be brushed off, which is a problem for AMD. At 1440p, while AMD can survive lightly ray traced games, the path tracing found in Alan Wake and Black Myth Wukong make AMD look like an 8-year-old.
Yeah, I have no idea why they're moving so quickly through these benchmarks individually. I think there's actually a lot that can be said here. So this is why, again, I also wanted to use this video for one. The explainers they actually include are pretty good, so thank you for that. But then stuff like this analysis, like here, the 7900 XTX cannot get you 30 FPS at 1440p. This is probably why something like the PS5 and Xbox Series X run this game internally at like 800p, right? The same actually goes even for like the PS5 Pro, but then it upscales nicely. That's a little bit different. But to me, obviously Nvidia is in a league of its own here, but even then you're like, oh, so we are actually getting a decent uplift now over the 4080 Super here. It's not huge, but it's at least measurable, right? But at this point, I would be like, okay, so if everything else was really improved in lockstep, right? Let's say we have this improvement of like 16% or whatever. I cannot do the math that quickly in my head. But like if it had like 20 gigs of memory with that, right? At least that way, so if a game ever wanted to scale 25% over 4080, but it couldn't because of memory limitations, then I could at least forgive it. But even here, it's like, really, we couldn't got like 5% more CUDA cores there to just get a little bit closer to like the 4090 performance. Like, look at the difference in 1% lows. Like 45 to 53 is actually pretty big. So yeah, it's not that it's bad, but it's just like falling short for a $1,000 card. Now, so does of course the 7900 XTX. But if you're getting that card, you probably know that you're just not playing at RT, certainly not at RT high. So it's a compromise you're willing to make for the lower price.
Year-old kid made it onto the field at an NFL game. Hopefully that will change with AMD's 9000 series of GPUs, but we don't know for sure. Today, across our suite of games, the 5080 maintains the same performance margin over the 4080 Super that we saw in our raster tests, but fails to scale as well as the 4090 does into 4K. Maybe the 4090's extra RT cores give it the edge, or maybe it's the VRAM. Check out this result in Alan Wake 2. Why did so many cards fail miserably? Guess now.
The 2080 Ti has 11 gigabytes of memory, which, by the way, is a completely ridiculous amount. But yeah, that means we have no cards. Oh, even 12 gigabytes actually fail. Now, that's 4K. You probably would be running at like 2.5 FPS on the 40. Well, no, it's a 4070 Super, 4070 Ti. Okay. So you would probably be running at like 12 FPS, okay? But yeah, the memory limitation really hits hard. This is something where you would run with some form of upscaler. And yeah, this is the kind of game where honestly, I kind of believe that they shot themselves in the foot with these high RT settings. I understand what they were going for. They were going for like a really future-proof game, right? Where they're like, oh, you can run it at 60 FPS at maybe 1440p, right? With the highest settings on the highest end card that is not yet to be announced. For 4K, maybe wait for another 2-3 generations. But I feel like a lot of PC hardware, PC users, for one, they run noticeably worse hardware, and they just look at the results and they were like, oh my god, my card probably cannot even run that game, even though it could with like RT off, with like FSR upscaling and things like that, right? But I think it just created this perception that this game is like absolutely unrunnable, which it isn't, but it is very demanding with RT on.
Did you say lack of VRAM? Well, you're right. And if you didn't say lack of VRAM, pretend that you did. 4K path-traced Alan Wake asks for over 15 gigabytes of VRAM on 50 series cards and over 16 on AMD cards. Anything less and it's wholly unplayable.
Well, yeah, for this specific preset, I mean, you could run the game at something even like 1800p, and realistically, there's always very little difference between like ultra quality and like high quality. So you could like turn some settings down and not actually see even that much visual difference, and like save literal gigabytes of memory usage. But that's also something that people don't really like recently, because I feel like in the past, if you got like a 1080 Ti, you got a card that just ran everything at high settings, with maybe some exceptions like hair rendering, right? Like that specific Nvidia hair tech that they launched. You were like, oh yeah, it could run that hair rendering, but it would get a noticeable performance drop. But then those settings were usually not even the default, right? Usually you would have to turn those on manually. But nowadays you now get games like Indiana Jones where RT is baked into the fundamentals of the game. Spider-Man 2, if they just use basically the code that exists on PS5, has ray tracing built into it. Now, it's not as demanding of ray tracing, at least in its reflections, but still, that's already a game changer to anybody who might have like a 1650 Ti or something like that, or even like a 2060 or even a 2070 with 8 gigs of RAM, where suddenly, oh, these games were optimized not only for ray tracing, but like at least 12 gigabytes of usable memory, because the consoles have 16, they dedicate about 2-3 gigabytes to the operating system, right? So that leaves you with around 12-13 gigabytes of usable memory. The PS5 Pro gives you a little more because it has 2 gigabytes of extra regular RAM inside. But yeah, like it's just so disappointing, I feel like, for many people to look at these demanding games and they see them at the highest quality settings and they're like, oh my god, it will take me literally thousands of dollars of multiple generational upgrades to actually run that game at those settings at like over 60 FPS in native 4K and stuff like that.
Well, we can't say that it causes a performance hit on the 5080. It highlights just how skimpy 16 gigabytes of VRAM feels on a $1,000 card, and how close we are to a future where it's necessary.
Oh, by the way, Steve, I think I said I read your message, but I didn't call out that it's actually a super chat. So thanks for the $249
for high-end gaming. And the more frustrating thing is that if you want more VRAM from Team Green, you literally have to spend twice as much for a 5090 or go back a generation or two. I digress. The rest of the 4K RT results show that the 5080 is still a mean green ray tracing machine. It's just not that much meaner than the 4080 Super. Another disappointing result for the 5000 series.
For productivity, the story is more mixed. While it doesn't do much to impress in our Blender render,
oh my god, why move on so freaking quickly from everything?
mixed. While it doesn't do much
So 5080, 4090, roughly. No, well, it doesn't match the 4090. Yeah, it's not super impressive. And hey, Mr. George Best, you asked for high-end Intel hardware. Well, maybe they could at least double that result.
To impress in our Blender render, in Premiere Pro, we can see that the updated media engine on the new 50 series puts in the work, beating the
Puget Bench and Premiere Pro. Okay, that's cool.
4090 by 5%, with a similar lead in DaVinci Resolve. We'd love to talk about improvements to encoding, but we're working on our benchmarks for that. Let us cook.
God, how I hate that. Like, my problem is, I'm sure you want to automate that shit too, right? No, I will not let you cook. Like, you're not dropped from the sky as a baby right now. You've been doing this shit for years. So you cannot be relying entirely on Puget Bench. At that point, just use freaking Puget Bench. And don't stop freaking talking about, oh, we are gonna make new benchmarks. Just take one 4K video file and run it, and then in the next review, guess what you can do? You don't have to even use that same 4K video file. Just standardize it in every single video, right? And maybe adjust the video file once a year, make sure that, and then run it. That's how it's done. There is not much more to it. You just want to put as few man hours into it, so it's cheaper for Linus to run this shit. So you want to automate it, so you need to write scripts that DaVinci Resolve and Premiere Pro actually work with. Like, you really telling me that, like, you only could run that benchmark? You yourself, who's currently, like, in the background, it looks like you're editing a video? You couldn't put a video on the 5080?
But who needs to shoot and edit videos when you could just generate garbage while wasting precious earthly resources?
At least that I agree
In
with.
AI, the 5080 manages a
4080 Super, 5080. So yeah, there are obviously AI improvements, gen to gen. Definitely the memory bandwidth helps here at least a little bit. But beyond just small models and stuff like that, 16 gigabytes for $1,000 is laughable at that point. You might, for some scenarios, even though the AI here will be a lot faster, but you might be better off with a 7900 XTX with its 24 gigabyte VRAM buffer, simply because a lot of tasks just won't fit onto the 5080. Yes, obviously this task fit, and you can see that it's like 80% faster than the 7900 XTX, but the moment it runs out of VRAM, now it will be probably like half as fast. So yeah, but obviously if you actually need something, then 5090s, Mac Studios, that's what you're looking at, like Quadro cards with 48 gigs of memory and more. That's what you're looking at, not 5080s. I promise you that.
20% lead over the 4080 Super in our text generation benchmarks, with the only hiccup being a smaller lead in our Phi 3.5. In our Stable Diffusion image...
Why are you moving so fast? I don't understand it. Like, you hold on so long for certain slides, but then you move throughout the others in seconds. Like literally seconds. Like, to the point of where the eye struggles to focus. 4080 Super, 16 gigabytes. 40... Yeah, okay. Like, there's nothing surprising here.
Image generation.
Like, if anything, like, there is a positive result here that it gets so close to the 4090
benchmarks. We see 16-ish% improvement over the 4080 Super,
which obviously Nvidia claimed like doubling and tripling of AI performance. That's because they were pushing like FP4 or integer 4 at that point. I'm not even sure. Yeah, not every AI workload will want to run at such a low precision level. Yes, AI is built for lower precision levels, but there comes a point at integer 2 or whatever where like you're so unprecise that it makes no sense. Yeah, so those generational uplifts that Nvidia was advertising, they're simply not there. They're not there for raster, because as much as they might have run some games that really benefited from higher memory bandwidth, that's just not true across the case. They do not give enough memory to really utilize even that much more raster performance. Not that the 5080 even has that many more shaders over the 4080 Super, right? You have to pay like 25% more money on the 5090 to get like 30% more shaders over the 4090. But then the ray tracing is improved basically in lockstep with rasterization, while previous generations have improved RT way more than rasterization. And now AI is improving, but only in like server class workloads, maybe, where you don't even have like the memory or the bandwidth even on a 5090. You would probably want like HBM memory cards with like 128 256 gigabytes to really utilize those crazy integer 4 like LLM workloads. And at that point I'm like, yeah, but did the 5080 really need that advertisement? Or, well, it kind of needed it because it didn't have anything else, but you as a consumer, did you really benefit from that marketing?
Is cool, I guess. Sadly, a lack of VRAM will limit the models you can play with.
True.
Womp womp. But this is positioned as a gaming card, so let's talk about the AI.
And again, you can buy an $800 Mac Mini with 24 gigabytes of memory. This is, by the way, why Apple can stick to their high RAM prices, because even though their RAM prices are ridiculous by themselves, compared to like what RAM costs on servers, and the fact that until Project Digits comes out, and now the problem is we are getting like RX 395 AI Max Plus whatever, right? We're basically getting Strix Halo APUs. And some are saying, oh my God, they will have like 128 gigabytes of memory. And they will have up to 96 gigabytes of that memory available for the GPU. So it's almost as good as like an M4 Max. But it's based on the RDNA 3.5 architecture. That same architecture that you see here with the 7900 XTX. So it just doesn't compete with Apple's neural engine. It doesn't compete with Nvidia's AI accelerators, right? And its bandwidth, it's built on a 256-bit bus using 8,000 megatransfers per second memory, while the M4 Max uses a 512-bit bus using 8533 megatransfers per second memory. So it has over double the bandwidth and a better architecture, and it's built on 3 nanometer, and it's paired with an ARM CPU, which makes it way more efficient as a package even before you consider the newer node. And it came out way prior. So yeah, NVIDIA really is, unfortunately, with the absolute highest end. Like, I'm talking stuff where it's like HBM memory and all that jazz. Like, in that way, they are in a class of their own.
Our text generation benchmarks.
Massive overhaul from DLSS 3.
Games run gooder.
DLSS 4 is a massive overhaul from DLSS 3. It switches from a CNN model to a transformer model. If you want to learn more about the theory, you should check out our 5090 review. What it means in practice is that DLSS 4 allows for better image quality at the same settings, with some caveats. Of course, it's the 50 series. There's going to be caveats. There's a performance hit using the new transformer model. While the effect is mild for things like super resolution, Digital Foundry saw that older cards can take a real hit from enabling certain features with the new model. But it scales better, which means that the 50 series and all of its Tensor Core chutzpah generates up to 3 frames for every rendered frame, essentially quadrupling your FPS. Multi-frame gen is impressive, and despite
I'm gonna comment least on this because I do highly recommend going to like Digital Foundry and seeing their analysis on this.
Natively at 30 FPS, each frame would have 33 milliseconds of latency. Running at 60 FPS would halve your latency to 16.66, doubling your FPS again, 8.33 milliseconds. You might see where I'm going with this. If you quadruple your 30 FPS game with FrameGen, you will still have that 33.33 milliseconds of latency, which is 25 milliseconds worse than rendering 120 FPS natively, a large disparity. Meanwhile, if you quadruple your 120 FPS game to 480 FPS, well, That only results in about a 6 millisecond difference in latency, which is far less noticeable. But here's the kicker. MFG has a performance overhead that will reduce your base frame rate. And the more frames you gen, the more overhead you need to contend with. That's why we don't see a literal quadrupling of frames.
Yeah, all of that
This
is
means
true,
that using
and
it to bump up an
I
already
think
low
that's
frame rate
also
will
why
make it feel
Apple
even
has not
worse
yet
to
gone
play
with
as
like
it adds
frame
more latency.
generation
There's
for
a ton of nuance to
metal.
this tech, and we would
Like they have
recommend
like
checking out
metal
Hardware Unboxed's
upscaling similar
excellent
to
video on it. The
DLSS
good
or
news is that
FSR,
multi-frame gen scales
but I
about
just
as well in the
don't
5080 as it
think
did in the
that
5090.
frame generation,
Hopefully this
especially
trend carries
given that
forward to the
Apple
lower
is
50
not
series because
really
it did
encouraging
not
people to run
carry
shit
over
at
to the lower end
240
of the 40
FPS,
series.
is anyway
So TLDR,
near in the
the higher
cards
your base
for
frame rate, the
Apple.
better your frame gen will feel, but the less you need it. Nvidia likes to pretend that frame gen is comparable to native rendering in their marketing,
not.
but it's just not. Should you forgo MFG and just stick
I'm
with the new
very
DLSS
happy
4
that they're
transformer
pretty
model, on the
honest
5080,
about
you'll
these
see about a
things.
5%
So
lower frame
I
rate
do
for the
criticize
improved
them
image
for
quality.
certain things
And
here, but at least
we think it's worth
I
a try.
don't think it's
Now,
a
all of this talk of
dishonest
frame rates and
review. I
latency
don't
might
think
have
it's
you wondering,
designed to
how does the
make
5080 fare
either
against sports?
AMD
Well,
or
it does a dang
Intel
good
or
job.
Nvidia
We
look
didn't test the rest
bad
of the
or
lineup today
good.
because, frankly,
I
any of
think
the
it's a
high-end
pretty
cards will give you a
actually
great experience
neutral
with esports
review.
titles. But this is a reminder that despite our dour and disappointed tone, it's still a very high-end, very performant card.
True.
And that also means it has big power draw.
The 5080 gets the same sleek and innovative double flow-through cooler as the 5090, allowing it to stay at a reasonable 70 degrees in combustor, despite pulling as much as 403 watts. If you're going to small form factor, you're far less likely
So the problem with the 5080 versus the 5090. So the 5090 is not $2,000, not even close. It's like $2,400, $2,800 on the AAB card. Now you can get that slick, slim, 2-slot model, but it will blow 600 watts of heat up to your CPU, depending on how your motherboard is built. Most are built that way, so with the GPU basically below the CPU, and with the double blow-through fans here, you will basically get all your heat directly at the GPU, at your CPU, which at that point might require you to get a different CPU cooler or a different case just to improve cooling overall. So not ideal, but it is a pretty impressive cooler nonetheless. Now here we are working with a 400 wattage card, maybe 500 with like a power virus workload. So not really something you will encounter in day-to-day scenarios. So my theory here is it's okay, right? So with the 5080, if you actually want the 5080, I would recommend getting that Founders Edition. Not only does it look sleek as F, but I do think that your potential issues with blowing heat up your GPU will be severely lessened by using way less heat. With a 5090, yes, you can also save money by going with the Founders Edition, but you could potentially create more problems internally for your build. And at that point, to compensate for that, you are either getting more expensive or just doubling down on the CPU cooler, or getting more fans into your system overall, which could potentially result in like really wonky airflow in your system if you overdo it. It's really good. This is why I don't like cards that are designed to consume that much power, especially if there's nothing like proprietary about them. Like the Mac Pro could consume however much power it wants on like its slot-in cards, because well, that system will be optimized for it. Since Apple is the only one doing it, right? Why not? But given that this is designed to go into like regular ITX builds, it's just like the 5090 is so freaking overkill. Like 600 watts is just insane for gaming power consumption.
to bump up against the thermal limits of this card than with the 5090. When gaming, the average temps drop further to 65 degrees thanks to the lower power budget. In F1,
Yeah, and by the way, that graph
than with the 5090. When gaming,
leads me almost to believe that they're using almost the exact same build of that cooler. So that results in the 5080 running cooler than the 5090. It basically consumes less wattage and therefore produces less heat, and therefore with almost maybe the same amount of cooling, it just stays cooler. Yeah, the 4080 is cheaper, but I'm not even sure if that's a founder's model.
The average temps drop further to 65 degrees thanks to the lower power budget. In F124, we see the 5080 pulling an average of 337 watts, nearly 15% more than the 40.
Ultra high preset, lowers better. Doesn't say if it's RT, because that could change a lot.
5080 Super. This nets around 14% more frames, which indicates no efficiency gains, just like we saw in the 5090.
Yep.
Bummer.
Feeling deflated? Me too. Taking everything into account, we have a next generation card that outperforms its last gen counterpart by 10 to 20% using roughly 15% more power. I mean, at least the price is the same. That's good.
Even then, it feels like it could have been a mid-cycle refresh or a 4080 Ti, given it doesn't.
Yeah, and some people will say, well, at least it has like new encoders and slightly improved AI stuff. Well, usually TIs and supermodels, they are basically the same die, but you get more of it. But sometimes you can also get like some architectural changes, like technically, and that's more going back to the Apple world of news. When you look at the M1 Pro, right, the M1 Pro had noticeable changes over the regular M1. Now, it's not the same die, but nothing could have prevented Nvidia from building a slightly different die on 4 nanometer a year prior if they wanted to. M1 Pro included, for example, ProRes encoders and decoders, and even had some very small architectural changes to the GPU. So I'll just encourage, and then there are changes to RAM that Nvidia does too. But for example, the M4 Pro utilizes 8533 memory, while the standard M4 utilizes, similar to the A18 and A18 Pro, it uses 7500 mega transfers per second memory. Whether it's a choice of efficiency, power consumption, heat generation, or maybe just to save some money, those are choices that you can make, and those choices, if you have a little bit of extra time, can result in some changes where the same generation of chip technically has slightly different capabilities. This is why this really could be a 4080 Ti Super.
Catch the 4090 in raw performance, something we really hoped it would do. At best, if you're considering the 4080 Super, the 5080 might be enough to push you over the edge to buy, at least at MSRP, but that's the hardest working S in the world. Because last-gen cards are nearly impossible to find at Nvidia's suggested price, and if the 5090 is anything to go by, this generation will be the same or even worse.
Yeah, Trump tariffs. And I don't want to talk too much about it because then the video gets like flagged for like political content. That's bullshit. But yeah, by the way, that isn't happening. I could see maybe 25%, definitely nothing 100%. I could also see a ton of exceptions being made. Also, don't forget that a ton of stuff might be made in Taiwan, but then even packaged in China. So we don't even know if he means like, oh, if it's a Taiwan-made chip, but then it's like packaged in the US, which technically would hit Intel the hardest, which is funny. But yeah, Apple, for example, gets their chips from Taiwan, but then packages them in China for the iPhone. So that could actually be a way to be exempt from tariffs, which of course would be stupid. It would entirely defeat the point. But all of Trump's tariffs are stupid, and everything in them defeats the point that he tries to make. And that's my political coverage of the day.
It feels like Nvidia just doesn't care much about gamers, and that's because they don't. They care about AI. That's what made them one of the most valuable companies in the world, and they're trying to use their large market share to move the market in their direction. They're saying, no, you don't want more raster. What the industry wants, nay, what it needs, is AI. And AI just so happens to need the proprietary features enabled by the chips that we produce.
I get it. If they were to admit that AI hardware wasn't the solution to every conceivable problem, then it would crater their stock price, a thing that actually just happened on Monday. The moment a Chinese AI company with limited access to Nvidia's best AI hardware supposedly overtook ChatGPT, Team Green's stock dropped 17 points. If the hype for AI and more specifically
Nvidia is down today 6.5%. The Nasdaq is down 1.2%. Apple is down 0.8%, so outperforming the broader tech market. About in line with the Dow Jones in general at minus 0.55%. Microsoft is down 1.25%, so roughly in line with the Nasdaq. Tesla is down 3%. People are not expecting too great of earnings results. So yeah, it's going to be interesting.
Hardware deflates, Jensen might have to trade his crocodile leather jacket for a regular leather jacket.
But with all of that said, without a clear competitor in the GPU
I'm
space,
pretty sure, like, no matter what, he will be able to afford crocodile leather for the rest of his life.
Nvidia will still sell a buttload of these to gamers and will continue to drive the industry in the direction of their choosing. So until AMD...
I mean, it's not quite their choosing, but yeah, they do set trends, but that's because they make their stuff eventually work, right? Like, they did not give up on DLSS after arguably messing it up originally with DLSS 1. They stopped making it game-specific, right? So they made it more generalized, made it easier to integrate into games. They dramatically improved quality with DLSS 2, right? They introduced technologies based on DLSS, whether it's DLAA, like anti-aliasing for native rendering resolutions, or ray reconstruction. So with DLS 3.5, there are specific AI algorithms to improve ray tracing. So if you actually don't run it with that DLSS, your ray tracing actually looks worse. Now, technically, that's a stupid way to combine those. I think marketing-wise, it should just be a part of RT. But hey, that's NVIDIA. They want to package everything as an AI feature, even if it's a ray tracing feature that happens to benefit from AI hardware. So yeah, but they have done a lot and they deserve a lot of praise. But similar to Apple, sometimes even though I believe a company might be the very best in its respective industry, I don't think that means that reviews should be without criticism. And especially when there's close to no value improvement after 2 years, and limitations like memory are now hitting harder than they did before. And there is no inflation over 2 years for a 4-nanometer card, right? Right now, like even back in the day with the 40 series card, like nothing happened dramatically since then. Like with the 3000 cards, at least I understand, like there was low supply due to the pandemic and inflation was really rising. But from the 4080 Super, not much has changed, be it inflation, be it world politics, tariffs are not yet in place or something like that, for it to justify not giving you better value. It should have 25% better value across the board, in my opinion, including memory. 4 gigs of extra memory, up to 20 gigs. Maybe it could have like gotten 24 gigs, but then $100 price increase, I would have been fine with that. But then that breaks the psychological barrier of like $999 versus $1099. So yeah, I understand that NVIDIA really likes their 50-60% profit margins, as does Apple. But then Apple delivered us the M4 16 gigabytes Mac Mini last year, and NVIDIA right now is giving us the 5080.
Intel brings the heat. This is what we got. It really kind
Unfortunately.
of feels like the Intel...
So I think that's enough as a statement here. So the last thing I want to cover today, well, let me actually look. There are actually a few Samsung things here. Neither is that big, but let me quickly look if there's any new stuff on the Apple side here. Apple accused of outsourcing unethical practices to other companies for AI profit. Yes, as they should, because there is no way in which they cannot compete, and everyone does AI at this point. So unless there are actual government regulations, I think people should shut up. Apple does not steal your data on the iPhone. Yes, Apple might buy data from companies that are not that trustworthy. Honestly, I have no problem with that because that data already exists. That data is already being sold and shit like that. There are questions about like whether or not Apple is also outsourcing the energy generation of AI, right, to other companies by integrating, for example, ChatGPT directly into Siri. However, I do believe that power consumption of those AIs when it comes to individual queries are up to the consumer to decide. What I do find is absolutely like unforgivable is just how much is being built for training, and with the expectation that inferencing will also be basically infinite. Like, no, make it smaller, make people wait a little bit more, use the more efficient hardware that's available. Like, you can build on 3 nanometer, force Nvidia if you have to, right? At least AMD builds like Zen 5C chiplets on 3 nanometer. Yeah, and beyond that, just hold on to your environmental goals, which Google announced, Microsoft announced, Amazon announced, but now all of them are pushing back that stuff because of AI. So Apple can be criticized here, but I genuinely do not believe that Apple is even worth mentioning right now. Is like one of the bad companies when it comes to AI. Just as I think that all the overreactions to the CSAM detection inside the Photos app were stupid. Hey, Apple will still react to that because they have to, but I am very open to criticizing Apple. I have criticized, for example, Tim Cook for like going to the inauguration of Trump and giving $1 million for that. But I do not think that these examples really warrant much scrutiny. Now, going to some Samsung stuff. Now, the Galaxy S25 Edge was teased very fittingly for a product called Edge. I'm so funny. At the very end of the announcement of the Galaxy S25 keynote, I guess, Samsung unpacked. What's interesting here is that, for one, we learned that the Edge would have a dual camera system, while previous rumors had pointed to it having a triple camera setup, supposedly with a 200 megapixel primary and then 250 megapixel sensors, one for the telephoto and then one for the ultra wides. Now we know, thanks to Samsung, that it will have a dual camera setup, and that supposedly will have a 200 megapixel primary and 12 megapixel ultra wide unit. But that's internal prototype information apparently. So it wouldn't get the newer ultra wide from the Galaxy S25 Ultra, which probably also means it doesn't get like the wider aperture of the S25 Ultra. And it should be noted that with 200 megapixels, it makes it very likely that it's a 1 by 1.3 inch sensor, but it doesn't have to be, and it doesn't necessarily, definitely doesn't have to be quite the latest generation. Now, I don't think it will be a sensor smaller than like 1 by 1.5 inches, which is basically the size of the camera sensor inside the regular iPhone 16 and 16 Plus, but definitely don't expect the camera system here to be on the same level as the Ultra. The Edge is a niche product. It's not even designed as a replacement for either the S25 or the 25 Plus. So Samsung is clearly just trying to find hardware that fits inside it without making it too expensive. I mean, Apple is doing the same, but Apple clearly has more of a vision for an iPhone Air than Samsung has for this Edge product. So yeah, my excitement for this is close to zero. I don't even think the S25 Ultra is that exciting, so why would I be excited for this? But I just wanted to cover it because in a few months we'll get final confirmation. We'll probably react to the reviews that we'll get at that point, and yeah, then we can analyze all of it together and see how these products basically perform in the end. Let me see if there's anything news here. So still no full reviews of the S25 Ultra. Yeah, for now it doesn't look like I'm missing out on anything. Then the last point for today is very, very brief coverage of the S25 Ultra battery life. Now, it should be noted that my best sources, the Tech Chap, even to a degree, Mr. Rooster Boss, but more like GSM Arena here for battery test, they have not yet published battery life tests for the S25 Ultra. So we have to rely on stuff here like Tom's Guide. Here are the results for the S25 Ultra. You see there is at least a little bit of an improvement. Now, this is very basic video playback, so that lends itself pretty nicely to the efficiency improvements of the 8 Elite. The 16 Pro Max really underperforms here relative to other tests. If I look here at the 16 Pro Max battery test, review, battery life. right? I see stuff like video playback for the iPhone here being at 22 hours, and then for the S24 Ultra being at like 16 hours. And let's add one of the large like silicon carbon batteries right now, Vivo X200 Pro. Right, you'll see 6,000 milliampere hours, almost 1/3 higher capacity than the iPhone 16 Pro Max, and it doesn't match it in any of those metrics. Now, yes, you can go crazy and go, what is it for like the, is it Magic 9 Pro? Or what's that gaming phone? Gaming phone. It's not the ROG phone. Oh, I always forget which one it is. Gaming phone 8 Elite. That's ROG. That's all ROG. Jesus. Change to English. The Red Magic. Yeah, okay. So looking here, I was not completely wrong with typing Magic. Wait. Did I not test Red Magic? There it is. Yeah, so 7,000 milliampere hour battery. You see, one thing where it definitely wins out is always audio calls. But even here, now granted, this is a large screen and it's not rounded, so it's edge to edge. But yeah, like whatever Tom's guide was doing here for just video playback tests definitely is interesting, because I do trust GSM Arena here. Yeah, so but granted, maybe if they're doing this with like browser usage, that could push it down. So I'm not sure, but you can see that here the iPhone is very close to the S25 Ultra. The S25 Ultra, at least in this kind of test, is superior to the S24 Ultra. And I actually would believe that in anything like except for gaming, the S25 Ultra probably gives you like 5% maybe better battery life than the S24 Ultra. But that also necessitates that, in my opinion, that the S24 Ultra performs worse than the 16 Pro Max. Because when you look at that one Mr. Who's the Boss test, where suddenly the S24 Ultra started winning versus the iPhone 15 Pro Max, which it originally lost to by like 2 hours, that is where it gets a little bit crazy for me. Yeah, but and then on YouTube, actually, when we go to downloads, so this is Xtech Care. If I'm pronouncing it correctly. Unfortunately, they're not Tech Droider, which is my favorite YouTube channel for battery tests, but they have tested the Magic 7 Pro, the iPhone 16 Pro Max, the S25 Ultra, and the Vivo X200 Pro. Don't care about the Magic, but yeah, the Galaxy, the iPhone, and the Vivo definitely are worth looking into. And that's the last topic of today. Let's get started.
Time for the epic battery drain test battle between the new Galaxy S25 Ultra, the iPhone 16 Pro Max, Vivo X200 Pro, and the Honor Magic 7 Pro. These are undoubtedly the most powerful phones on the planet right now. We've got the best smartphone chips.
Yeah, I mean, the Honor does not have the largest battery, like in comparison to a lot of like even more high-end Chinese phones, but at least it's another good version to test, because it does have the Snapdragon 8 Elite.
On the table here, starting with the Dimensity 9400 inside the Vivo X200 Pro, Snapdragon 8 Elite inside the Honor Magic 7 Pro, and the Snapdragon 8 Elite for Galaxy inside the S25 Ultra, and finally Apple 18 Pro inside the iPhone 16 Pro Max. Looking at the battery specs, Vivo has the biggest battery coming at 6,000 mAh, followed by the Honor Magic 7 Pro, then Galaxy S25 Ultra, and finally the smallest battery is on the iPhone 16 Pro Max, coming at 4,685 mAh.
So whether Apple does it with stacked batteries or silicon carbon batteries or however else, I do want them to go at least close to 5,000 milliampere hours, preferably something like 5,200. I don't need Apple to compromise on speakers, microphones, cameras to go up to 6,000. I don't expect them to get the highest density batteries right away, but it's definitely time for them to at least hit 5,000
milliampere. Before we begin, just want to make it clear that there are no SIM cards inside these phones. We're going to be using Wi-Fi exclusively. I've also calibrated the brightness, and all the settings on these phones are set on default.
So this is why I actually am looking into this video, because this is calibration that I'm not sure that some other big YouTubers are doing. And by the way, you can see that the Galaxy here, while it does have a pretty slim bezel, it's definitely not like earth-shattering as some had predicted.
But you get it right out of the box, so nothing is changed. Oh, before we begin, don't miss out on that exciting Galaxy S25 series exclusive discount mentioned in the description below. With that out of the way, kick back, relax, enjoy the music, and I'll see you guys on the other side.
So the tests here are, what is it? That's TikTok. Okay. I mean, might not be as relevant in the US in a few weeks, but yeah, it's not bad. But is it all TikTok? Cannot be, right? So the Chinese phone performed best with TikTok. ChatGPT. Okay, I'm not sure if that's a very relevant workflow. How long does he use that for? Huh. So the iPhone seems... Wait, did the iPhone here really perform the best? Like, the iPhone lost 5%. This one lost like... So it's... Well, the iPhone and the Galaxy lost about the same of energy. So that leads the question, which one was dramatically faster? No, they lost all about similar amounts, which is, so for now, the Vivo does have the lead. So, and by the way, this is already, we have talked about blatant copying, but why does the Honor need a a dynamic island that is this thin? At that point, just... So that's... I don't even know. Is that Facebook? Okay, so... Oh, yeah. Okay, it shows that right here. YouTube, more relevant to me, definitely. Definitely a shout out here to the low reflectivity screen on the Samsung. It is rumored that Apple might be integrating something either on the 17 Pro series or the 18 Pro series. So so that camera stuff in the end really benefits the iPhone, which let me look even at the images that were shown here, because I do not think that's a very fair test to run. Like, because it's a completely artificial way, right? Samsung sees you're looking at the back, at basically you're too close to focus, right? So what it does instead, it shows you basically a black image to preserve energy, and probably because it doesn't see that much more. Now this one, it shows you a lot of gray. The iPhone shows gray for the actual main image, but it doesn't show you more than black outside of it, as does the Vivo, but it does show you definitely just more gray. So this test is weird, because I do think that it's very, very generously benefiting the Samsung. Also, did he really drain like 40% of the battery just for the camera? Because that would be a completely disproportionate amount. I think that would be really bad testing. Yeah, okay, so it killed the Samsung, even though the Samsung objectively was doing the least on the screen. So that's actually a terrible result for the Samsung, but then it's a nothing burger either way. Also, there are big differences usually with how phones can calculate their battery, like below 20%, definitely below 10%. So sometimes a phone might be at 10%, but then the battery runs out like that, right? Similar how you know how from 100% to 99%, it usually takes way longer to drop than from 99% then to 98% or to 97%. And that's because 100 capacity at full, it's not always easy to calculate when it loses exactly 1%. But by the time the battery knows, oh, I'm at 99, so I roughly have an estimate to go down. And it's similar when you go to 20 or to 10, below 10%, especially. You're like, oh, I'm almost empty, but I'm not sure if I maybe am surprisingly more full. Maybe I'll just find a few more electrons, right? That's a very gross oversimplification. But this is why the iPhone, for example, could lose between up until 50% versus the Vivo, but then catch up. That being said, I'm not sure that any of that is being really relevant here. I think what is relevant is just that these phones are probably treating their cameras here very, very differently. Yeah, the iPhone's camera battery is fantastic, by the way.
Alrighty, what a bad
Okay, so the results I don't like. So the Red Magic ran for 11 hours and 8 minutes. The iPhone ran for 11 hours and 30 minutes. Oh, wait, were those already part 2 and 1? Oh yeah, the Samsung ran I believe the least, right? For around 11 hours. The Vivo for 11 hours and 8. No, wait, which one? That's the Red Magic. And then the Vivo for 11 and 15. So all of these phones were very close, and I do believe that the end of the test was pretty bad. So that's, again, the reason why I usually don't go to this channel for that. I do give them credit for standardizing stuff like the display brightness, but like usually I recommend going to the reviews of this channel. So they did compare gaming shit and stuff like that. Not too interested, honestly, in that. I just don't game enough on my phone anymore. But yeah, this was a battery drain test from 3 weeks ago, which we could briefly look into, because probably it will be just that plus the Galaxy. I don't think that their methodology will change. So camera test. They also put camera test at the end, which, I mean, I guess it makes sense for maybe like tourist stuff, right? Where you're capturing a lot of photos and videos throughout the day. So let me just look at the final results. So the Pixel at 10 hours and 15 minutes got pretty warm at 40 degrees. Definitely not a great result, but it's definitely better than like the previous generation Pixel.
Then it was the OnePlus 12.
That's the OnePlus 12? What? Why does he say 12? That should be the 13.
At 10R31, a decent job
Oh.
done.
Wait, is that the last gen? He says OnePlus 13, iPhone 16 Pro Max, Galaxy S25 Ultra. Oh, and there were like some last gen
I would say. Samsung S24 Ultra went 2 minutes longer at 10R33. That's an amazing score. Then shockingly, it was the iPhone 16 Pro Max went down at 11 hours 18 minutes. Phenomenal job done considering got a really small battery at 4680 mAh. The OnePlus 13 went down next at 11 hours 32 minutes, which is an amazing score. Says a larger battery, OS 15 and 8 Elite chipset is definitely helping a lot. The champion of this battle is Xiaomi 15 Pro with HyperOS 2.2 icing on top. This device went 11 hours 48 minutes. That is impressive. So your thoughts?
How
this
big
battle
was the
is
difference to the
15
iPhone?
Edge.
Okay, half an hour. So, okay. Definitely good results here across the board. Often the iPhone wins these tests. It might start losing now that the competition has much better battery capacities. And that's what I'm here for. That's what I absolutely love to see. Because while I don't expect Apple to put in 6,000 milliamp hour batteries, if Apple can deliver these kinds of results at for less than 4,700, imagine where they can be with like a 10-12% increase to like 5,200. I think that will be very cool, and I'm really disappointing that Samsung has not yet given us a larger battery. They even like dumped down the S Pen, and they made the device thinner and lighter, and somehow all of that had priority over a bigger battery. That to me are really baffling choices, especially since I do believe that while yes, Apple competes more in China than Samsung, Bless me, sorry. But I do believe that in countries like in European countries, for example, Samsung competes way more with Chinese brands even than Apple does compete with those Chinese brands, because they're more like value focused. And also like those 8 Elite devices, man, at 47 freaking degrees, that's hot. Like, look, the iPhone was at 38 and even the Pixel was below 40. The Samsung was 42, so that's not too cold. And then the last gen OnePlus. Yeah. Okay. So interesting results. Not necessarily quite what I would have expected. And yeah, Samsung is getting some praise across the board for the anti-reflective coating, both on the last gen Ultra and now the new one. So it will be interesting to see if maybe in real world scenarios actually really helps preserve battery. I definitely wouldn't result in me giving them a point in the camera comparison like Mr. Who's the Boss did, but yeah, that's a very different discussion. Let me look if the big guys had something new to say. So SuperSaf has a, usually whenever he makes these comparisons, they are very spec sheet reading, so it's not really something I look forward to. Max Tech, they do have nice comparisons back to back, so there was nothing crazy in here. I briefly looked into that. The speaker was pretty good on the S25 Ultra, so it was pretty much on par with the 16 Pro Max, which was a nice surprise. So I'm not gonna hide that data from you that I briefly found somewhere. And yeah, Mr. Who's the Boss still does not have like a full-on phone comparison with like other things considered other than camera, but I would also be resting if I could get 3 million views in 3 days. MKBHD probably does not have a full-on review for the S25 Ultra, but then again, I would probably be resting too if my Samsung's Project Muhan video could make 2 million views in 2 days. So yeah, I understand them. Wish the guys all the best. That's about it for today's video. Thank you guys for tuning in. Thank you for commenting, for liking, for sharing, for all that stuff. Whenever you catch me live, consider leaving a super chat or a super sticker. You can also support this channel by becoming a channel member right here on YouTube or a supporter over on Patreon. And beyond all that, just let me know what you would like to see me cover next. We'll definitely look into full-on S25 Ultra reviews. I'm glad that I could give you some coverage on more PC-focused hardware. I know we had less viewers today, primarily because that's not really the bread and butter of this channel. But hey, it is interesting as long as it's interesting. I do not expect to be covering like the AMD 9070 and 9070 XT. So maybe very briefly in like some website rather than watching full-on videos. So at least wanted to give you a baseline with some nice NVIDIA coverage. So expect me back at the worst on Sunday, but hopefully I'll find some other time to stream. Not sure if I'm meeting with friends tomorrow. On Friday, my mom is coming to visit, so forgive me for being a bit busy. It's all very nice stuff, so not always work stress stuff. So thank you very, very much for all of that. Yeah, so I'll see you guys next time. This is Mark Tech, tuning out.